Now, our next guest, Lee. Now, I'm going to try to say your name. You can just correct me later. Chung Chi Lee? Qing? Chung Chi Qing Lee.
Yes.
Lee, for short. And I do apologize. I just like to be able to give it a go and just, say names the right way. Lee is an award-winning entrepreneur and the founder and principal of Creod Group of Companies. He is a vice chairman of the City of London Westminster Conservative Association Chinese Group, as well as a committee member for the Conservative West End Ward and international board member of Creative Industries Federation. Creod is a visionary brand of pioneering interdisciplinary architectural design, innovation, technology, and development companies, defining what they do as digital master builders. Creod developed the integrated design for manufacture, assembly, and I'll start again, design for manufacture, assembly, intelligent automation, KIDIA, application software to create changes in AEC industries. Founded by Lee in 2012 and based in London, team members come from a range of diverse cultural, educational, and geographic backgrounds to work in a highly dynamic professional environment. Let me just make sure that this goes to that. Next time, remind me. I give you Lee.
Hi, good afternoon, ladies and gentlemen. My name's Chung Lee, aka Lee. I'm the founder. I'm glad to be here, first of all. Thank you for having me, Nick. And I'm the founder and the CVO of Creod Companies. The first question people usually ask, what is Creod? Some say, you create something odd. Creod. Yes, we do actually, but just in a very nice way. Actually, Creod is a multidisciplinary architectural design, technology, and construction companies. And it consists of, and we use design innovation technology to create changes in the AEC, architecture, engineering, and construction industries. The Creod brands consist of award-winning architectural practice. It's called Creod Architecture. And we have a startup company called the Creod Integrated Smart Solutions, KISS. And under that brand, we have formed the Creod Integrated DfMA Intelligent Automation Tool software. And following that, because we do the digital assembly simulation, so the question is, what can builders do at can't? So it turns out we're the contractors now. And we're also, using our own technology. We developed the building systems called the Creod Aeronautics Building Systems, CAPS. So we're launching Creod Homes, which is going to be fully customized, parametric, and ready for fabrication with a clear costing and deadline, etc. So firstly, I'd like to share my personal story. It's the Creod London Olympic Pavilion, which I designed and built for the Olympic Games back in summer 2012. It all started with an idea. My background is computational design and digital fabrication, which is still playing a very important role in the AEC industries. So following my studies, I came up with this design. It's a pavilion. And when I asked around, I wanted to build it. When I asked my colleagues and the teachers, they said it's impossible. Why? The reason because I was a young graduate and I just simply didn't have the recipe of success because so much I didn't know. And there's a real world out there. There's so many challenges. So the question arises, who is the client? Who's going to pay for this? Where do you build this? How to do this? Who's going to solve all the design problems? I couldn't answer all these questions, but I firmly believe I can do something. So I transformed from a student into an entrepreneur, started pitching, a range of companies. I sent thousands of letters, spent £2,000 on stamps and envelopes, pitching this idea. After thousands of attempts and failures, I've managed to convince a range of companies who believed in my dream. So they kindly sponsor their products, services, materials, and also the land outside the O2 arena. So this is the pavilion I designed. Is a movable kind of structure. It consists of 3 identical elements on clusters, so you can push them around, creating different types of exhibition spaces during the day. At night, you can push them together. It glows in the dark like a Chinese lantern. It also secures itself. So each pavilion is a very small job. It's super complex because it's double curvature. And each pavilion consists of 997 unique pieces. Imagine if each member is 1 millimeter bigger, 997 pieces later, is 1 meter off. So you could never build this. So when I asked my engineer, how much would my pavilion cost? They said it's going to be £1 million. I was so surprised. So why? Why is it so expensive? Because it's the level of complexity of this kind of project. Look at this young man. The O2 arena behind you was £380 million original budget, and the final cost was nearly tripled. Based on your experience, if you've never built anything in your life and you're trying to do something like this, good luck. I wish you success. That was the comments I had from my colleagues. And so this is the very complex project. It was our first attempt. It was a fully paperless design, engineering, manufacturing, and construction. And gives an idea. Oh, sorry. It gives an idea. The steel plant. I closely work with the steel fabricator, and even understand the chamfer for welding, and give the 100% detailed model. I didn't understand the term. I didn't know the term DfMA, Design for Manufacturing Assembly, but I called it Design Information Manufacturing Modeling. So and so this is what's was it played at? Oh. That's how it was made, because each member is cut in 3-dimensional angle. It couldn't be made by hand. And the accuracy needs to be aerospace accuracy, plus minus 0.02 millimeter. And the only paper we had was this A3 assembly diagram. I didn't want to bring my shiny MacBook Pro to the building site. So now we can use these iPads. And we successfully delivered this project. And actually behind the scene, I created a new workflow. But the workflow is very, very complicated because it requires a very specialist skill, the programming, scripting, and then from the knowledge sharing and the product life cycle management point of view. This is not transferable because each designer, or with a computational design, they always come with a different solution, the same outcome but a different journey in terms of programming. So I found this very difficult to manage. And also from the business point of view, you can see this kind of a job, it requires a special skill. And that's the risk, So I realized that I must come up with a system so that you can automate the process so we can focus on the business growth rather than the dependencies on a highly skilled people, which is very, very dangerous in the business world. And from that, we started looking into the housing development. And I must thank Nick and his colleagues from Howick, and also my engineer, Nigel, Ideas Global. My structural engineer specializes in light gauge steel frame. So we've been in the background developing an automated light gauge steel frame software on Dassault systems. And this is a job we were involved, working with Nigel closely, and also Nick. We've been doing this automation. So the principle is, just automate the process, really. I think this job it can be easily generated in, computer does the job, which is 3 clicks. And I would say it was 3 hours. Yeah, we can change a better computer. And the principle is very simple surface. This example, a surface or a solid, a block. So it generates a wireframe so I can pass it to my engineer Nigel to do the structural analysis. Once we can replace the stick models, it generates 100% detailed steel frame. And also in the background, it automates the drawings, which I don't need. It's just for the building control, and more importantly, it's the manufacturing code. So I can pass it to Viri, the one of our manufacturers based in Lithuania. So in this way, we in control because, you know, the steel frame itself is just the beginning, actually. We need to consider the, the facade systems, you know, the brick slips or cladding panels. So I have invested and developed a range of automation tools. For example, this just a random surface, you know. So you just click a button. It tells you we need 7,300 bricks. So the steel frame for Howick, so, you know, just manufacturing code, we can give it to any manufacturers in the world. And the rest of it, built for materials. So people always ask me, how much? How much does a building cost? How do I suppose to know? You know, I can't tell you. But now, actually, it's an informative design approach from concept design or the RIBA, the beginning of the RIBA stage 2. We can immediately arrive to the end of RIBA stage 4. So if you're the brick slips, site and concept, yeah, we might consider other cladding panels, say steel panels. But the steel price has doubled since the beginning of the pandemic. So we might consider a composite cladding systems. So this kind of informative design approach, it gives you certainty when you're running a business as a developer. Because once you decide the material, say Kingspan cladding panel, but now the price has doubled, suddenly your project is no longer viable. But if you knew this, you can do an educated guess what's going to be in steel price in the next few years. So we can think, oh, we're going to use the composite panels because the pricing is not jumping too much. So once you've got the planning permission, you can't really, it's not that easy to change it. So this is the solution. We work working towards the developers as well as a principal contractor, building a range of buildings, residential developments in London, and there's potential an apartment block in Birmingham as well. So this is the job. We are the principal contractor. So we provide turnkey solutions. So this is one of the ugly projects. My investor bought it with a land with a planning permission, and our job is so many roles as a turnkey contractor, lead architect, project manager, and the principal contractor, and also the MEP contract. That's another challenge. You know, it's a very steep learning curve. I never understood why this industry worked in the way. But anyway, we're solving problems step by step. So this is the risk assessment. Really, we don't use any drawings. We had to produce a drawing for my subcontractor, the basement contract, setting out drawings. But as you can see, the site is very, very tight. You've got the illegal basement developments next door. We just don't know where they are, how deep they are. We didn't know the condition. We did a point cloud scan, which is 12 gigabytes. And initially we had this a ground beam on the site. And I realized that's just very risky. Even we did the 12 pits, we dig down. And actually, the internal wall is 107 millimeter away from the boundary line. So if we build a trench, it will crash into their building. There will be some claims in the future. So before the construction started, we saw the problems. We changed the design. It just keeps us out of trouble, keep everyone out of trouble. And also the construction simulation is very important because my background is not an architect really. We design buildings, and we're not building contractors. So we do using simulation assembly sequencing. So we understand from the detail of the 3D, it drives Gantt chart program. So understand any changes, any impact, you consider dependencies a month ahead. So it puts them in a really, really strong position. Understand, it's all about risk management at the end of the day, finance as well. So we program everything in terms of logistics, how things go, how things run, which is going very well. And this one we're finalizing detail with my structural engineer. So we just automate the process. Another thing is the MEPs as well. But the current issue with all this framing software, Techno, anything, the problem with them is they want the final design. But the problem is the final design doesn't really exist until we get the MEP designs because it clashes. So the thing is, the current software we have in the market is very, if you want to make a change, it's quite tricky. So for us, it's just a few button clicks. I'll show you some more examples. So, we can understand, any design changes, we can just change accordingly. This is fully parametric from the steel frame, the building envelopes, internal fit out plasterboard, how many sheets of plasterboard, boarding, everything. So that spits out the cost, a spreadsheet, shopping list. So what I'm introducing here is open book contract. Costs, this is my labor, and this is our profit, which is 28% profit on the construction is really, really high because of the efficiency. And we don't need people. That's the beauty of it. And this is another case study we did. This is the primary house we designed. We had 2 architects before us, both from Grand Designs. It's a greenbelt development, and so they didn't get a planning permission. So we came along. Yeah, we're very good at plannings as well. So we got the planning, and it's a private house, really nice actually. The cost for this, actually we changed the design, and even double high sliding doors. So the price of this job is £180 per square foot. It's pretty high end. And entire simulation, automation simulation, that gives an idea, so from the concept design, our Create tool, automation tool, and it clicks to the garage. Very conceptual design, reference surfaces. You click on the panel, in seconds it generates 100% detailed cladding panels. And you click again, it will generate all the cladding rails. So the way we program is it definitely going to work. If it doesn't, it won't generate it anyway. So there's a engineering template we created. And as a behind the scene, it generates manufacturing shop drawings, manufacturing code if you require. Anything quantifiable. It just gives a spreadsheet, how much people are interested. So this is a level detail, fully automated. Maybe some manual tweak, but pretty much it's just a click. So the idea is my receptionist can click and do the job without realizing what's been done, but its job is done. All we need to do is due diligence. Check. Is that okay? It should be, yeah. Just double check. And this is the envelope, just the envelope itself. The building we changed 12 times. The beginning we didn't have the budget for the underfloor heating, and the client wanted, because they're private clients, and they wanted the roof pitch to be steeper. They want to see different options. And if you work in the traditional way, you're the architects. You produce design intent. You give the appointed principal contractor. Principal contractor needs to hire a facade engineer. Facade engineer needs to work with a manufacturer. So if you make any changes, the chain of effects, people want more money, need more time as well. So that's how the relationship goes pear-shaped, So now we have this solution. We made the changes in the front of them. You click, 7 minutes, no hard feelings. What else? So 12 changes. It automates everything. And last minute, we have the budget for underfloor heating. Good news. Not good news for us. But yeah, it's okay. We have the software solution. And there's a digital mock-up, So we need to understand how to assemble them. Every single part is it's a digital twin to the real world. And this is our engineering template when we created this, ready for manufacturing, we created unfolded drawings and everything. DXF, if you need it, or just CNC, spreadsheets, manufacturing codes. In terms of bending parts, it's a K factor. Obviously, different manufacturers have a different bending, different machines. We just need to double check. What's your bending K factor? 3.728. Yeah, we just change that. Automated. Job done. And steel frame, light gauge steel frame. And yes, this is the final, the entire building envelope. Assembly drawings. It tells you how many different panels and the quantity. Shop drawings, all done, automated, by the way. We didn't touch anything. It's done by itself. So that's the beauty of it, efficiency. And also, how do we build this? People don't understand. They don't have the real skills, unconventional construction methods. So we develop just very, very simple tools. It guides people what needs to be assembled. So it could also simulate the construction process. We know how many people and how long it's going to take. So what we're promoting is very liberal approach. Is if your job during the next day like this, in theory, Lee and Nick can assemble 5 panels. If we did 10, we'll be double paid because we encourage you to work faster or pay more. But ultimately, as a building contractor, it doesn't affect my budget. Is the job is done much quicker. People are more encouraged. So win-win scenario in the case. And yeah, this is the work we do. Thank you very much for listening. Thank you.